for a little over 3 months now. It's an honor of a lifetime. But I'll tell you, one of the things that I've enjoyed most about this entire process is now, since being nominated, this is my second trip to Arizona State University. And I've had the opportunity to meet a lot of the professors here, a lot of the researchers, and in fact spend a lot of time with the students. And what an amazing, amazing institution this is. And I want to be really clear, this is an institution that has gone through a lot of change, a massive transformation. You can see it as you walk about the campus. And I will tell you, an honor is getting to know Dr. Michael Crow, the leader of this transformational change. I had never heard the word transdisciplinary. I've heard interdisciplinary, I've heard all kinds of other words about organizational structures, but it's almost like post-disciplinary, which of course you talked about in your remarks just a few minutes ago. But it's not just something that's on the billboard, it's not something that's just in the literature, it's something that has become a part of this institution in a way that goes all the way from the top to the bottom. By the way, I don't know if you guys have heard, but this is the #1 most innovative university in the country. You said #1 and you followed it up by, we're ahead of, I think you said Stanford, and what was the other one, MIT? Well, if you're #1, aren't you ahead of everybody? You really got to clarify that? You got something against MIT and Stanford? Oh, they were second and third, okay. Just to be clear, they were second and third. Okay, got it. Well, what an amazing opportunity, and it's great to be back at Arizona State University with so many friends. Matt Salmon, of course, we served together in the House of Representatives. We were classmates. It was my first time to serve in the House, your second time to serve in the House, but of course you represented Arizona splendidly and worked well together in so many different ways. You're a true friend and will be for life, so thank you for your leadership as well. And of course, I commend Shay Stotts as well. Great hire. And of course, he's worked very diligently making sure all of this goes smoothly. And so what a great opportunity to be here. I'll start by talking about, and we talked about this last night, Dr. Crow, at dinner. I feel like one of my jobs as the NASA administrator is to make sure that America understands how important space is to their everyday lives. Because a lot of people simply don't know. I come from the state of Oklahoma, and we don't have, in the state of Oklahoma, we don't have a major NASA center, and we don't have a university that is so involved the way Arizona State University is in NASA activities, or the University of Arizona. But I'll tell you, a lot of people don't realize it, but just think about this. The way we communicate. A lot of people in this room probably have DirecTV or Dish Network. Maybe you get internet broadband from space. As a Navy pilot and as an Air Force Air National Guard pilot, we use high-resolution motion picture imagery that needs to be sent all over the world, and we do it with space-based architectures. So the way we communicate, the way we navigate, the way we produce food in this country. I spent some time at a swim meet for my kids in Oklahoma the other day, and I was sitting next to a gentleman who was a farmer in Nebraska. And I was telling the story last night. He asked me. He said, so what do you do? My kids and his grandkids are in the swim meet. He says, so what do you do? I said, well, I work for NASA. And he says, well, what do you do for NASA? Well, I'm the NASA administrator. Well, what does the NASA administrator do? Well, I kind of run it. and he says to me, well, let me tell you what's happening in Nebraska. So he starts talking about this consortium of other farmers that they've put together, and they're educating farmers throughout Nebraska on how to utilize NASA technology, space-based technology, to increase their crop yields. So when to plant and when to harvest, and how much to water and when to water, all of these capabilities are available to farmers in Nebraska, not just to feed the United States of America, but to in fact feed the entire world. And so these are capabilities that are based on our investments in space. So the way we communicate, the way we navigate, the way we produce food, the way we produce energy, the way we do disaster relief, the way we do national security and defense. Even people think about weather. You get up in the morning, you turn on the TV, and you see that green blob that's going to be coming over your neck of the woods at a certain time of the day. 80% of the data that goes into creating that green blob that goes into the numerical weather models, 80% of that data comes from satellites built by NASA. Now, they're NOAA operated, but they're NASA built satellites. And then the way we understand climate. Oh, by the way, that green blob, I've noticed, doesn't really affect Arizona, so some in here might not be aware of that green blob. But I'll tell you, in Oklahoma, we're aware of it. We're very well aware of it. And in fact, we're working very hard to move to a day where we have 0 deaths from tornadoes in a state like Oklahoma, which is critically important, and I think we can achieve that, in no small part because of space-based capabilities. So the way we predict weather, the way we do understand the climate, and a lot of people don't realize the way we do banking in this country. You know, every banking transaction in this country requires a GPS timing signal. So if we lose timing, there's no banking. In other words, there's no milk in the grocery store in a matter of 3 days. For any banking transaction that happens, it requires that GPS timing signal. You think about the power grid. You know, timing signal from GPS is necessary to regulate flows of electricity on the power grid and to regulate flows of data on the electromagnetic spectrum when you think about cell towers and when you think about terrestrial landlines and networks in general require timing signals from GPS. So a lot of people don't realize how space has improved our everyday lives. And in fact, you could say that we are dependent on space. Not just dependent. Some of our potential adversaries across the world call space the American Achilles heel. Because if we do go a day without space, it would be an existential threat to the United States of America. That's how dependent we have become on space. So all that being said, I want to talk for a second about some of the things this administration has done as it relates to space and how I, as the NASA administrator, am responsible for carrying out some of these activities. The very first space policy directive that the president put out, Space Policy Directive 1, focuses on going back to the moon. I don't like to use the word going back to the moon. We're going forward to the moon. We're going to the moon in a way that we've never done before. I want to start by making sure everybody in this room understands that I'm aware of how important Arizona State University is to our lunar activities, operating cameras on the Lunar Reconnaissance Orbiter, and of course the Luna Map mission that's upcoming. These capabilities where we're going to understand where the hydrogen is on the surface of the moon. In other words, where the water is. Hundreds of billions of tons of water ice that we now understand to be on the surface of the moon in the polar regions. And Arizona State University is collecting all that data and operating those instruments to make it possible. That's a really big deal for NASA. It's a really big deal for our country. And so I want you to be aware how grateful we are to this university for those activities. So going forward, we're going forward to the moon. When I say we're doing it different than we've ever done before, there's a number of changes that were in Space Policy Directive 1. Number one, the key word in there is sustainably. We've seen the Space Exploration Initiative, SEI, going back maybe 20 years, maybe longer than that, 25 years. We've seen the Vision for Space Exploration going back maybe 15 years. And each one of these different visions is the United States going to the moon. And in each case, we get distracted, or the budgets change, and ultimately it never materializes. So I get the question all the time, how do we know that this is not Lucy and the football again? How do you ensure us that this time we're actually going to the moon, which we haven't done since 1972? Well, the answer is we have capabilities today that didn't exist even 5 or 10 years ago. So the key word is sustainability. How do we create a sustainable architecture? Well, it starts with the fact that we now understand the benefits to reusability. We've seen reusable rockets. We've seen payloads get deployed and the rockets come back to Earth and then be reused. And not just once, but twice and 3 times. And we're talking about eventually maybe rockets being used 10, 15, 20, 30 times. What that does is it drops the cost of space and it increases the access to space. It democratizes space. Reusability of launch is a big piece of what's going to enable us to make sure that this time we really do go to the moon. And this is not Lucy and the football again. But it's not just reusability in the term of access to space. It's reusability in the sense that we want everything between the Earth and the Moon to be reusable. So we want tugs between low Earth orbit and lunar orbit to be reusable. And we want the Gateway, if you guys are familiar with the Gateway, think about a space station in orbit around the Moon, a near rectilinear halo orbit where it doesn't have to burn very much fuel and it can stay there for a very long period of time. We want that space station to be an open architecture space station so that our commercial partners and our international partners can actually present their ideas and join the effort to not only go to the Moon, but to take advantage of the resources of the Moon. So it says we're going to have this and we want landers that go back and forth between the Gateway, think of a space station in orbit around the Moon, solar electric propulsion. We want landers to go back and forth from the Gateway to the surface of the Moon over and over again. We want reusable landers. Here's the other thing that's important to note. From 1969, when we first landed on the Moon, all the way up until 2008, 39 years, we believed that the Moon was bone dry, or at least a lot of people did. Now I know the 50-pound heads in this room knew better, but maybe some people didn't. But a lot of people in this country and around the world believed that the Moon was bone dry. 2008, India had a mission, and they discovered that there's water on the surface of the Moon. A high probability that there's water. Then NASA does a mission in 2009, and they make assessments that there's potentially hundreds of billions of tons of water ice at the poles of the Moon. That was in 2009. So the question is this: how did we go all of those years without knowing that? And what else do we not know about the Moon? There's a lot to learn. And of course, this university is involved in it as much as anybody on the planet. But when you think about what else could be on the surface of the Moon, you think about, we're familiar with rare earth metals. Well, they're not earth metals at all. Of course, this university has the biggest collection of asteroids of any collection in the world. Those rare earth metals are asteroid impacts, but they're very valuable, platinum group metals. Well, you look at the Moon has all kinds of impacts, and there's not an active geology, and there's not an active hydrosphere, although we do now know that there is a hydrosphere on the Moon. If you can imagine that, new water is being created on the Moon every day from charged particles coming out of the sun, which is, again, a new discovery of NASA in partnership with universities. So you look at these capabilities and these things that we're learning every day. So when I talk about this space station in orbit around the Moon, what this gains us is more access to more parts of the Moon than we've ever had before. We don't want to miss something like the fact that there's hundreds of billions of tons of water ice on the surface of the Moon. Now, water ice, people are like, okay, well, there's water ice on this. What does that mean? Well, it's ultimately water to drink for life support. It's air to breathe for life support. You crack it into hydrogen and oxygen, put it into cryogenic form, and it's rocket fuel. Same rocket fuel that's going to power the Space Launch System. Same rocket fuel that powered the space shuttles. So all of that is available to us on the surface of the Moon. And if there is a discovery of platinum group metals on the surface of the Moon in quantities that could be in the multiple trillions of dollars, friends, that could change the balance of power on Earth. So in my view, the United States of America ought to be the first to make those discoveries, or at least not fall behind in making those discoveries. So there's a lot of reasons to go back to the Moon. We want to go in a sustainable way. When I say sustainable, everything is reusable. We want to utilize our commercial partners that even 5 or 10 years ago we didn't have ability to utilize. And we want as many international partners as are willing to join. We want all of that. I have to pause 1 second. I'm going to continue this 1 second. There's another Arizona, and I need to thank. I just looking across the room. I just keyed in on my Chief Financial Officer, Jeff DeWitt, who was the State Treasurer of Arizona. I want to be clear. I apologize for stealing him from Arizona because I'm sure he was an amazing State Treasurer. But we are tremendously honored to have him working at NASA. I hope it's good for Arizona that he's working at NASA. It's good for me to have him as the CFO. This is a guy who has an amazing intellect, an amazing ability to communicate. Jeff DeWitt, thank you for being here today. I don't know why they got you way back there in the back. You probably chose back there, but that's all right. You'll be on a panel pretty soon. But here's the thing. You think about, we want more access to more parts of the moon than ever before. We missed it back in 1969 to 1972 when we did the Apollo mission. How did we miss it? Well, we missed it because we landed in the equatorial regions. And we presumed from that we understood more about the moon than we actually understood. It'd be like landing in the Middle East and trying to make determinations about Hawaii, right? It doesn't work that way. But ultimately, that's kind of what we did on the surface of the moon. But we're learning more every day. And we want more access to more parts of the moon than ever before. We want a reusable architecture, sustainable for the long term, international partners, commercial partners. And this is another change in the policy for the moon. The other change is this. We want to utilize the resources of the moon. That's never been American policy before, but it's American policy now. So that's a big charge for us. And in order to utilize the resources, we need that sustainable architecture so we can go back and forth. Now, that sustainable architecture, of course, includes humans, but it includes robots and rovers and landers, more landers than we've ever had before. We want commercial partners developing their own capabilities, doing their own prospecting on the surface of the moon. We want international partners joining us in this effort as well. So there's a lot of opportunity here when it comes to going back to the moon. The other important piece of this is that the entire architecture ultimately would be replicable at Mars. People say, why are we going to the moon? We've been to the moon before. Well, there's a lot we need to learn scientifically about the moon even right now that we haven't known yet. But even more so, the moon is our best opportunity to retire risk and prove capabilities and generate the technology that ultimately gets us to Mars. The first gateway, that orbiter, with solar electric propulsion in the near rectilinear halo orbit, which is ultimately going to be able to go to the L1 and L2 around the moon, again, providing our landers more access to more parts of the moon than ever before. That first gateway is all about the moon. Second gateway is a deep space transport. And that's our opportunity to go on to Mars. So we want all of these technologies to be produced with an eye for going to Mars. Now, all of that being said, there's another piece to the moon that I think is important. We know, because of the International Space Station and the research that's been done thereon, we know that on the physiological effects, we somewhat know, we mostly know the physiological effects to humans in a microgravity environment. We know that during the course of a 6-month stay, humans are going to lose 1 to 3% of their bone mass in a given month. We know that the neurovestibular system goes through some physiological changes, and it takes a while after you get back into a gravity environment. It takes a while to get back to work in a regular way. We know that the heart gets deconditioned when you're in a microgravity environment. And of course, that sometimes makes it really hard for astronauts to stand up when they get back into a gravity environment. And to the extent they do stand up, some of them get really, really ill because of the neurovestibular challenges. We know that, actually we don't know, but we understand that there is going to be a very harsh radiation environment in deep space that we don't even have in low Earth orbit on the International Space Station. So there's a lot of challenges here that we have to overcome physiologically. And we're learning more and more every day from astronauts that are staying on the International Space Station longer and longer. Some things might not be so positive. But here's what we know. We know that the moon is a 3-day journey home. And if we can have an astronaut in orbit of the Earth for 6 months and then send them to the moon, we can prove out, does the moon mitigate all of those challenges in a gravity well that's 1/6 that of the Earth? Can all of those physiological effects be reversed in a gravity well of the moon? And if the answer is yes, then it would stand to reason that it would be reversed in a gravity well 1/3 that of the Earth, Mars. So the moon is our best opportunity. Imagine this. Imagine being an astronaut, because I've heard this argument. People say, well, for every dollar we spend going to the moon is a dollar we don't spend going to Mars. I've heard that argument, and maybe some of you have as well. Imagine being an astronaut and spending 7 to 9 months in a capsule in a journey on the way to Mars. And then once you land on Mars, you have to be perfect. You have to do everything correctly. You have to be as precise as you have ever been. And if you're not, of course, the end result is really bad. In fact, death. And oh, by the way, you can't come home for another 2 years, which is how long it takes before the Earth and Mars orbits align to come home. So we don't want to prove all of this capability out on Mars. We want to prove it out within the Earth-Moon system. We want to prove it out where there's a 3-day journey home. And in fact, if you read the Pathways report from 2014, done by Mitch Daniels, it was a bipartisan commission. He's now the president of Purdue University. The Pathways report was very clear that the best way to get to Mars fastest is to utilize the moon. So that's ultimately what we're doing here. So, reusability builds a sustainable architecture. Number 2, international partners. There's more space agencies from all around the world than ever before. Commercial partners. And then ultimately utilizing the resources of the moon, retiring risk, and making all of these technologies and capabilities replicable at Mars. Friends, that's Space Policy Directive 1 in a nutshell. No pressure. That's a lot. And it's not going to happen overnight, but it's important for it to happen for the strategic interests of the United States. Now, Space Policy Directive 2, focused on the regulatory environment. And of course, we have some folks here that are going to be talking about this a little later on, so I won't spend too much time on it. But when you think about the regulatory environment, I'll just mention a few things. Remember in Space Policy Directive 1, we're going to take advantage of commercial partnerships? Well, we have a challenge in the United States of America when we have these non-traditional space-based capabilities that are being provided commercially that ultimately there's no regulatory environment for. And under the Outer Space Treaty, Article 6, it says that anything launched from the United States soil has to be authorized and continually supervised by the United States government. So if we're going to have commercial habitats in space, commercial space stations, who in the United States government does the authorization and continuing supervision for those activities? Well, according to the State Department, nobody. Nobody does the authorization and continuing supervision of those activities. So when you go to get a license from the FAA, Office of Commercial Space Transportation, for launching an activity into space, and in that payload review process, they ping the Department of State and say, hey, are we in keeping with our international obligations? The Department of State says, well, we don't know, because we have nobody that can tell us if we are in keeping with our Outer Space Treaty obligations. So all of a sudden, capital that's in the United States decides to go abroad. And capital that's abroad stays abroad. And we want to do just the opposite. We want capital in the United States to stay here, and we want capital abroad to come to the United States. We want to reverse that. So we need an agency that has the authority to say, yes, these commercial habitats are authorized and continually supervised by somebody. In this case, Space Policy Directive 2 puts it at the Commerce Department, which I think is appropriate, by the way. And it's not just habitats. Think about rendezvous and proximity operations in low Earth orbit. Who in the United States government is going to authorize and continually supervise rendezvous and proximity operations? In other words, satellites flying in formation with other satellites, grappling other satellites, ultimately servicing other satellites, doing maintenance on other satellites, robotic maintenance of satellites. Great capabilities currently being developed by NASA in partnership with universities. Well, who in the United States government authorizes and continually supervises that activity? The answer again is nobody. When it comes to prospecting the moon, who authorizes that? Who continually supervises it? Nobody. When it comes to mining an asteroid, the answer is nobody. So in order to be in compliance with the Outer Space Treaty, authorization and continuing supervision, we have to make that a done deal. And under this administration, don't get me wrong, it's going to be very permissive. This administration wants to do all of these things, and so I would imagine it's not going to be any problem whatsoever. But ultimately, a future administration could say, actually, no, we don't have that authority. And in fact, we've been in that case in the not too distant past. So we want to codify it. We want to be permanent. So all of these non-traditional space activities, we need to be successful. Now, NASA doesn't get involved in that. It's not our job. But here's the thing. If we're going to commercialize low Earth orbit, we want that to happen. Why? Because then NASA can be one customer of many customers in low Earth orbit. One customer of many customers, driving down our costs. And we want a lot of providers that are competing on not just price, but innovation. Increasing our ability to do more in low Earth orbit than we can even do right now on the International Space Station. That's the ultimate objective here. So these are activities that are going to be focused on Space Policy Directive 2. There's other things in there about improving regulations at FAA, AST. There's other capabilities in there. When you think about, NOAA and the Commerce Department, the remote sensing elements of NOAA and the regulations therein. So there's a lot in Space Policy Directive 2, but we need Space Policy Directive 2 to be successful for NASA to be able to take advantage of all those capabilities. Then there's Space Policy Directive 3. And I'm looking at Mariba Jah because he and I have been talking about this for a very long time. You know, not too long ago, NASA was one of 13 space agencies. It's called the Interagency Space Debris Coordination Committee. NASA and these space agencies came together and they did an assessment. And the assessment was that every 5 to 9 years there will be a collision in low Earth orbit similar to the Iridium Cosmos collision of 2009. That particular collision resulted in thousands of pieces of orbital debris that are trackable. In other words, 10 centimeters or bigger. Well, that means there's thousands of more pieces that are not trackable, 10 centimeters or smaller, and they're equally as dangerous to the orbital regime. And by the way, dangerous to American astronauts and our international partner astronauts on the International Space Station. So, Space Policy Directive 3 focuses on space situational awareness and space traffic management. So right now, the way it works is all of this activity is being done by the Department of Defense through Strategic Command, the Joint Space Operations Center, which operates under Strategic Command, and the JSPOC, the Joint Space Operations Center, Vandenberg Air Force Base. They're collecting data from sensors all over the world. We're talking about telescopes and radars. They take all the data, they do conjunction analysis and warning, and they do it for the entire world, and they do it for free. Which, by the way, is a good thing because we have to make sure that we're protecting the space environment. The problem is, space has become more contested. And in fact, you could say that it's become hostile. And those Air Force space operators are being distracted. In fact, we've had testimony on the committees on which I serve. 70% of the manpower is being used to do conjunction analysis and warning, not for national security interests, but because commercial satellites might run into each other, or international satellites might run into a commercial satellite. So 70% of the manpower is being used for that. And the DoD is coming to Congress, which, as mentioned, I was in Congress before I was an NASA administrator. The DoD is coming to Congress and saying, we don't want to be the FAA for space anymore. It's time for this activity to be done by somebody else because you know, the Air Force, we've got other things that we need to be worrying about right now. And so we want to help that along. So what NASA is going to do, what needs to happen is all that data, the JSPOC, needs to be ported, the unclassified data needs to be teleported out and put into a civilian agency where it can be combined with commercial data and international data to create that single integrated space picture so we can get better space situational awareness and better space traffic management than ever before. So that's Space Policy Directive 3. Now, a lot of people have heard the president and the vice president talk about the Space Force. That's not a space policy directive at this point. I would imagine one day it will be. There's a lot to be sorted out between now and then. But I will tell you this. As a member of the House of Representatives, I have voted on it 3 times. The Strategic Forces Subcommittee, which is responsible for all of our national security space-based capabilities. I voted on it in the Armed Services Committee, and then I voted on it on the full floor of the House of Representatives. Now, when I voted on it on the floor of the House, it passed with 344 votes to 81. Strong bipartisan support in the House of Representatives. So I'll just share with you kind of what the thoughts here are, what we thought about in the House of Representatives, and that is this. If you think about what a military service is and does, Organize, train, and equip. That's what we do. Organize, train, and equip. Military services don't go to war. Wars are conducted by combatant commands. The military services organize, train, and equip, and then they present forces to combatant commands, which are geographic in nature. A lot of people are familiar with CENTCOM in the Middle East. Some people are familiar with Strategic Command. So the idea is having a separate Space Force. If you were to look at Air Force Space Command, they're the ones that do the organizing and the training for the Air Force folks that are involved in space activity. And if you look at the Space and Missile Systems Center, they're the ones that do the acquisition. All of that currently resides within the Air Force. If you just carve those two functions out and you make it a separate Space Force and you give it a general or an admiral that serves on the Joint Chiefs and you give it its own service secretary, now you've got the organize, train, and equip function. And then if you were to create a combatant command, think of Air Force Space Command, a combatant command that's functional in nature, that's focused on fighting and winning wars in space, that would be the Air Force or the U.S. Space Command. So organize, train, and equip, combatant command, you put those functions together, put it under a service secretary, that's ultimately the Space Force. That's how we thought about it in the House of Representatives. We didn't give it its own service secretary. We had it reporting to the Secretary of the Air Force. Just like the Marine Corps reports to the Secretary of the Navy, we had a Space Corps reporting to the Secretary of the Air Force. But we called it the Space Corps. The President took it up a notch, and I think correctly. He said he wants a service separate, but equal in stature to the Air Force. So that's really what we're talking about when we talk about the Space Force. Now let me tell you this, because I get this question all the time. What does this have to do with NASA? Well, it doesn't. What I just described doesn't specifically have to. Here's what we do. We do science. We do discovery. We do exploration. That's who NASA is. That's what we do. But I will also tell you that we have a high need for space security. And to the extent that some kind of kinetic war extends into space, friends, it's our astronauts that are on the line, plus hundreds of billions of dollars worth of taxpayer investment that is on the line. So I have been in the House of Representatives, along with a broad bipartisan group, a supporter of the Space Force. And NASA, of course, is keen on ensuring that space is preserved for the future. The idea being, if the adversaries of the United States understand that the so-called Achilles heel is not an Achilles heel, if they understand that, we want to deter them from ever wrecking the orbital regimes that NASA uses. We want to deter them from ever wrecking the orbital regimes that ultimately enable us to have more access to space than ever before. Now, I'm going to talk about one last thing, and then I'll turn it over to some questions. We've talked about how important space is to everybody's lives. We've talked about Space Policy Directive 1, we're going to the moon. Space Policy Directive 2, we're focusing on an entirely different regulatory regime for space activities that are done commercially. Space Policy Directive 3,